Happy Wednesday. Today we are starting our new unit, and our new unit is titled Rational Functions. Today we do not have any slides for our notes, so just pulling up a blank Notability document will do. And to make sure that everybody has Notability opened on their iPads, look at people next to you, and if they don't have Notability open on their iPads, raise your hand and go, ooh, they don't. Okay, if we do not have Notability open or we don't have an iPad, do we have pieces of paper that we can use? So let's get out like a notebook or something. Excellent. Okay, rational functions. Sounds intimidating. Here's what a rational function is. You take a polynomial. Who can give me an example of what a polynomial is? Somebody shout out an example. I'll give you a hint. It's what you just took a test on.
X squared plus 3x plus.
Great, that's a polynomial. Another polynomial, that's another polynomial. If you take this polynomial and you divide it by another polynomial, so like for instance, we have two polynomials over here, and if we took one and divided it by the other, that's a rational function. That's what a rational function is. It's as simple as that. Except, let's go through a few examples because I'm seeing some kind of confused faces here. So this right here, this on top, that's a polynomial. That's a polynomial. So if you have a polynomial divided by a polynomial, that'll get you a rational function. So that's a rational function. If I had is that a rational function? Yeah, because this is a polynomial. That's also a polynomial. We've got two polynomials, and they're divided by each other. So it works. What about this? Is that a rational function? Why not? If I asked you, here's 4. I want to write 4 as a fraction. 4 over 1 is a fraction. If I wanted to write 2x plus 3 as a fraction, can't I do the same thing? So you have 2x plus 3 over 1. Is 1 a polynomial? Let's think about it. If I wrote 1 x, is that the same thing as 1? No, because this is x to the first power. What if I said this was x to the 0th power? Is that 1? Is that a polynomial? It's got an x to some power. It's not negative, and it's not a fraction. So it works. That's a polynomial. So this is a polynomial, which means that this is a polynomial, which means that that's a polynomial, and that's a polynomial. Wait, 4 over 1 is a rational function. Isn't that weird? So now you can go and you can tell your parents tonight, or you can tell some other friends that you have, hey, did you know that in elementary school, we were adding and subtracting rational functions? And they'll be like, what? What even is that? And you'll be like, well, we were. Fun fact, if you go to some kind of elementary school teacher and tell them the same thing, they would also freak out. Because they probably don't think of it as a rational function. You might also be freaking out right now. But okay, so 1 is a polynomial. 2x plus 3 is a polynomial. That means that this right here is a rational function. How about is that a rational function? If you think yes, thumbs up. If you think no, thumbs down. And if you're just completely lost, thumbs sideways. Thumbs up if you think rational function, thumbs down if you think not a rational function, thumbs sideways if you're just completely lost. I'm waiting for everybody to show me a thumb. Okay. If we're trying to find a rational function, here's your two-step process. Is this a polynomial? Is this a polynomial? So, of the numerator and the denominator, which one do we know for sure is a polynomial? Okay, so this is a polynomial, so check. Okay, now we got to figure out this top part here. Is that a polynomial? You have a square root of x, and that's probably what's kind of puzzling you. If you have the square root of x, how can you write the square root of x to some power? Do you know? You have a fraction power that is the same thing as a root. So since we have 1 over 2 here, that means it's a square root. If we had x to the 1/3, what kind of root would that be? That would be a cubed root. Okay, so here we have 3 times x to the 1/2 power. Can we have a fraction in our power if we have a polynomial? No, definitely not. So we have a fraction here. Because we have a fraction, that means that's not a polynomial, which means this is not a polynomial. Exactly, this is not a rational function. Okay, that's 1/2 of what we have to learn today, and you learned it in like 5 minutes. Okay, the other thing that we are going to learn today is, well, let's start with this first. Let's go with please determine whether this is a rational function or not. Once you have decided, thumbs up if it is, thumbs down if it isn't, thumbs sideways if you are completely lost. Okay, so, once again, is that a polynomial? Is that a polynomial? Polynomial divided by polynomial, this is a rational function. Except this rational function here, what do you notice about the numerator? It can be factored. And as Mr. Server said, so we need to factor this. I will give you a few moments to factor this. Now I'll pause the recording while we do. I've given you a little bit of time to factor. Audrey, can you help us factor this? X minus 2 and x. Wait, what?
X minus 1 and x plus 5.
Okay. X minus 1, x plus 5. Okay. Can we factor the bottom?
No.
No. But wait, there's more. Did you guys grow up on those infomercials? Yeah, like those are, okay. I don't know if you guys are like at that age or it's like, no, we just grew up watching Netflix. I don't know. Okay. Okay, good. I'm glad I'm not that old yet. Okay, if we look at this, what do you notice? Yes, Quinn.
X plus 5 is on the bottom.
We have a common factor of x plus 5 in our numerator and our denominator. If we do, you can cancel them out. You don't need them anymore. So our rational function can simplify to x minus 1. And that is still a polynomial, and it is still a rational function. Okay. For the rest of today, simplifying rational functions is all we are doing. Which seems like, oh, this is going to be easy. Except, how many different ways do you know to factor now? Like a whole bunch? So, today we are going to be using all of those different ways of factoring, which is why this is harder than it might seem at first. So we're going to start easy and work our way up. Please simplify this rational function. I will pause while you are simplifying. Jake, help me with the first step.
Yeah, Jake.
Factor out of 5.
And what do you end up with inside the parentheses?
X plus 5.
Calling somebody.
8.
Bottom.
Factor out of 3. And then get x plus 5.
Calling somebody. Katrina, calling somebody. Okay. Quinn, what are we doing next?
I think you can put the 5 and the 3 in parentheses and then just do 1 x plus 4. No, maybe not. Oh, they cancel out. Yeah.
We have an x plus 5 in the denominator and in the numerator. So we can cancel them out, indeed. And we are just left with 5/3. Is 5/3 a rational function?
Yes.
Yeah, it is. Okay. New problem. It's a little bit harder, but I think you can get there. Simplify this rational function. I'll pause while you do. Frank, help us with this, simplifying this first one. Okay. Please kindly return materials to whomever they belong to. Okay. I would like a volunteer. Actually, Frank just calling somebody. Yeah.
X minus 2 and 1 and then plus 3 again.
Okay. We have factored the top, we have factored the bottom. Is there anything we can cancel?
Yes.
X plus 3 and X plus 3.
Thank you, Will. So all we're left with is x plus 4 over x minus 2. Can that simplify? No. Nope. That is our simplified rational expression. Our rational function. Okay. We're going to continue getting harder. Yes.
Off-topic questions. If you want us to drop off for they said we were gonna. I drop off just in case. It's due today. The drop off is due Wednesday, so I should do it now just in case.
Yes, that is a great thing, and I forgot But yes,
It
please.
says due Wednesday, not Tuesday. I have so many missing assignments because we haven't graded them in class yet. They're just like homework. Well, no, it's doesn't show up this year.
Okay.
I put
That is a good question. Please Dropbox the review for yesterday's test. Dropbox it in general. Please take 20 seconds right now to do it so you don't forget.
Dropbox review.
Dropbox your review.
Review guide from the last thing.
Yes. The review guide from the polynomial test you just took. Please Dropbox your review. I will give you 5 more seconds to do so before we are moving on. Not really, because I've been saying rational more. Okay. Let's see. Resuming now that you have Dropboxed your review for your polynomial test. Simplify this rational function. I will pause while you do. Okay. Connor, can you help us solve this top part?
Yeah, so you factor out of 2.
Okay, we're factoring out of 2. And if we factor out of 2, what do you get inside the parentheses?
X squared minus 4x plus 3.
Alright, we factored out of 2. And there are 2 paths we can take from this point. You can say, okay, this right here becomes x minus 1 and x minus 3. And you can factor it out. Otherwise, if you look at your top and your bottom, what do you notice? They're the same. You can just cancel it. So it just equals 2. Is 2 a rational function?
Yes.
And it's a rational function. Okay. When does this period end? I never know. 44? Oh, we got plenty of time. There are still a few more. Here, I'll give you a hard one. The hard one's next. Ready? Do we need to separate? Answer yourself, please. There's your numerator. I am making sure that I write every single part of this correctly because I didn't first period and they were like, you can't even factor this. And they were right. There you go. Please simplify this rational function.
Oh boy.
Here's a hint. If you have something that is to the cubed, you can't really factor it like you did quadratics. So think about the way that you learned how to factor with higher degree polynomials. That's my hint for you. I will pause while you're working. I would like somebody to tell me, how are we going to factor this? What method? Can you say it a little bit louder so everybody can hear, including Jake and Katrina? Divide and conquer. So we're going to split it down the middle there. If we're dividing and conquering from these 2 terms, what's in common? So we have an x squared, and what is left is an x plus 2. Okay, now we have this side, and we can factor out a positive 4. And then we have x plus 2 remaining. So there's our top. Now we got to factor out our bottom. Okay, same thing for this bottom part. We have an x squared that we can factor out, and it leaves behind an x plus 3. What factors out of that second part?
-4.
A -4. And then we're left with an x plus 3 again. And if we look at this factor by grouping that we just did, then we know that we have an x plus 2 in common. So we're going to factor out an x plus 2 from both terms here. And if we factor out an x plus 2, that means we can get rid of them there because we factored it out. So we have an x plus 2. What's remaining now? X squared plus 4. So there is our numerator. We do the same thing on the bottom. We have an x plus 3 term in common. So you can factor out an x plus 3. Then we've canceled those out. So what's left is an x squared minus 4. Now here is why completely factoring is so important. If you look at this, does anything cancel?
Not in the current.
In this current state, no. But is it completely factored?
No.
George, what do we have to do?
You can do the x squared minus 4, so that is the x plus 2 and x minus 2.
This x squared minus 4 becomes x plus 2, x minus 2. Does this x squared plus 4 give us 2 real factors? No. So leave this as it is. That's fine, and you can't factor that one anymore. But now that we have an x plus 2 and an x minus 2 instead of this, what cancels? This x plus 2 cancels that x plus 2, and what we have remaining is an x squared plus 4 over x plus 3 times x minus 2. Okay. I know I just asked you what time this period ended. 44, right? Oh, it's still 28. Okay. I will give you one more problem. And this problem will take like 3 minutes, tops. And then you can have the rest of the time to work. Okay? This problem there's your numerator. And there's your denominator.
How do you know rightly that there's this denominator?
Because I worked backwards to make these.
No, she's magic.
I'm not quite as magical as Mr. Server just yet. I hope to achieve his magicalness one day. That's because all of mine are planned out, so hopefully I don't have any mistakes. Sometimes I still do though. So. Okay, I will provide you with time to work on this one. If you are having trouble factoring this one, let me know and I can help you out. But I'll pause while we work. Do we need to go over this one as a class, or
No.
we got the answer?
Yes.
Okay, what is the answer? Ian, tell us. Close. I think it's just an x squared. I don't think it's an x squared plus 1. Show of hands, who got this?
Now I did.
Okay, show of hands, who needs to go over this? Nobody?
Wait, real quick. So that's the final answer?
This should be your final answer here. Okay, if you're having trouble with this one and you would like to ask a question about it, you have work time for the remaining class period, and you have a homework that is a PDF.
We have to do the whole thing. It's like 12.
There are 12 questions, but as a going away present,
Let's do 6.
let's cross off 3 of them.
How about we meet you in the middle at
I will cross off,
5, 9, 10.
I'll compromise with you. We'll cross off 9, 10, and 11.
Okay.
What about 12?
Cross off 9.
You have to do 12.
Yes.
You can do 12. It's not that bad. 9, 10, and 11. 9 and 10 are kind of hard. 11 is kind of easy. 9, 10, and 11 we are skipping. Do the rest. That is 9, and you have about 9 minutes left. You can get it done. Okay, that is all the material we are covering for today, so I'm going to stop the recording here.